starting with what we already know, let's identify all of our asymptotes. Okay, because we're still looking at H and K driving our asymptotes. So, looking at letter A, what's my vertical asymptote going to be? X equals, my vertical asymptote is x equals 3. Good. And then my horizontal asymptote is y equals 0. Good. And we know that because of the HK values. All right, looking at letter B. What is my H value? Well, it's 2, so my vertical asymptote is x equals 2, and y equals -1. Good. So this is the same stuff that we did on Friday. Looking at C, what is my vertical asymptote? X equals -1, and y equals +2. Right? So all the same things that we did on Friday. So I can fill in a little bit of information down below. So this is just a little review. I have x equals 3, y equals 0. Please make sure when you're writing your equations, they have an equal sign. Make sure you know that vertical lines start with x equals and horizontal lines start with y equals. If you're just giving me a value here, I'm going to assume you don't know and I'm going to mark it wrong. All right. So now let's go back and figure out if we can find an easy way to plot some points. So on Friday, if it was the parent function, I could go from the intersection of the asymptotes, I could go over 1 and F1. Now I have this A value of 2. So I want to go over 1 unit from that vertical asymptote. What's the x value 1 unit to the right of the vertical asymptote? 4. I'm going to plug a 4 into this equation and see what happens. So I'm going to have 2 over 4 minus 3 squared. So what's 4 minus 3? What's 1 squared? 1. So 2 over 1 equals 2. So if my x value is 4, my y value is 2. All right. Now let's go 1 unit to the left of that vertical asymptote. So what's the value of x 1 unit to the left of the vertical asymptote? 2. So let me plug in a 2 to my equation here. So I have 2 over 2 minus 3 squared. So what's 2 minus 3? -1. What's -1 squared? +1. So I get the same value, y equals 2. All right, we know when we have an x squared in the denominator, our curves are going to both head the same direction, right? They're both going to go up here. And then I'm going to swing these down. And I can still sketch. And they're just pulled further away from that intersection of the asymptote. So instead of going over 1, up 1 from the intersection of the asymptotes, I went over 1 and up 2. What was my A value? 2. Let's see if there's do you think that that's a pattern? Let's find out, okay? Let's try that again. Let's algebraically figure out my points and see if my conjecture is I can go over 1 and up the A value, okay? And see if that holds true. So looking at B, bless you, what is the x value 1 unit to the right of the vertical asymptote? 3. So let's plug that in. So -4 over 3 minus 2. So 3 minus 2 is 1. So -4 minus 1 equals -5. So when my x value is 3, my y value is -5. 1, 2, 3, 4, 5. So that's going to be down here. Move that up a tiny bit there. All right. So now let's do the same thing, 1 unit to the left of the vertical asymptote. So what value of x is 1 unit to the left of the vertical asymptote? 1. So if I have negative 4 and I have 1 minus 2 minus 1. So what's 1 minus 2? Negative 1. So negative 4 over negative 1 is positive 4, and then I still have to subtract 1. This gives me 3. So when x is 1, y is 1, 2, 3. All right, so here in example B, I don't have an x squared in the denominator. I just have an x in the denominator. So this is when we had, in the parent function, I had a curve in quadrant 1 and a curve in quadrant 3. So here I'm going to have the same idea. I'm going to have curves if I thought about this as quadrant 1, 2, 3, 4, in 2 and 4 this time, because my a value is negative. From where the asymptotes intersect, if I go to the right one, how much did I go down? I went down 4. So does that hold true with my conjecture that we thought a minute ago? I can go over 1 and then up the a value or down the a value, depending if it's positive or negative. So I'm just going to sketch here, and I'm going to sketch here. In pre-cal, they'll make you pick a couple more points to get a few more exact values. I'm interested in those 2 exact values, and the rest can be a sketch. All right, so let's use that idea to do this last one. Hiding my a value. There we go. So my a value is negative 3. So from where the asymptotes intersect, I'm going to go to the right one, and then where? Down 3. 1, 2, 3, because my a value is 3. Now, because I've got this quantity squared in my denominator, when I go left 1, which direction will I go? Also down 3. Because these curves are going to both be going down. There we go. The rest of this. This should be pretty straightforward, just like we saw on Friday. So my domain is negative infinity to 3, and from 3 to infinity. My range is from 0 to positive infinity. Because it was quantity squared, you're only going to see one piece of the range, versus in B, we're going to have the union. So we'll go from negative infinity to 2, and 2 to infinity for the domain, and the range will go from negative infinity to negative 1, and negative 1 to infinity. All right, this last one will go from negative infinity to negative 1, and negative 1 to infinity. What about the range? What's my range of this one going to be? Negative infinity to 2. Make sure we only have parentheses here. None of these values are included. So the second part of your homework is going to be, given the graphs of a rational function, I need you to be able to write the equations. So the very first thing you're going to want to do is to draw your asymptotes. All right, so I'm going to do that all at one time. I'm going to draw all my asymptotes. So on this first example, I've got a horizontal asymptote here at negative 2 and a vertical asymptote at 4. I've got a horizontal asymptote at y equals 3 and a vertical asymptote at x equals 0. I've got a horizontal asymptote at y equals negative 1, 2, 3, 4, and a vertical asymptote at x equals negative 3. All right, so that'll be the first thing you'll want to do. And this is going to help us find our h's and our k's. All right, I don't know what this is. So if I look at this first one, is my denominator going to be x squared or just x? Just x, okay, because the curves are not both going up or both going down. The parent function was shifted to the right 1, 2, 3, 4 units. So I'm going to write x minus 4 in the denominator. It's shifted down 2 units. minus 2. Remember, it's not an equation without an equal sign, so don't forget your y equals. So the last thing I need to do is determine my a value. All right, so I'm going to go to where your asymptotes intersect. I'm going to go to the right one and up until I hit the graph, and this will just be a 1. All right, so if I look at B, my vertical asymptote is x equals 0, so I'm just going to put an x down there by itself. It was shifted up 1, 2, 3 units, so I need a plus 3 for my k value. From where your asymptotes intersect, I'm going to go to the right one and down 2. So what's your a value going to be? Negative 2, because I went to the right one and down 2. All right, last one. The parent function is shifted to the left 3 units. So I'm going to write x plus 3. What else do I need to do to this denominator? I need to square this because the curves are both going up. By the way, if I look back at letter A, I don't have to have those parentheses in the denominator. It's okay if you don't. Just be very careful that that k value is off to the right. My k value in letter C, the parent function is shifted down 1, 2, 3, 4. So I'm going to have a minus 4 over here. From where the asymptotes intersect, if I go to the right one, I'm going to go up 1, 2. So my a value is